Okay. So write down the definitions of a stretch and dilation. We talked a little bit about that. Oops, that's supposed to say shape. When the dimensions of the shape are not scaled equally. Not is the key word there. So stretch is gonna like morph the shape or change the shape. It's gonna like pull it, stretch it, make it look not like the original shape. Dilation is the opposite when the dimensions are scaled equally or proportionally. Okay, so again, dilation would be the proportional one, so the one that looks like the original. So looking at these examples, this is written in the format, I don't know if this is written. This is written in the format of our coordinate rules. So we did this for translation, rotation, and reflection. Going from my original x, y to like, remember when we did like x plus 3, that meant to move right 3 places on the graph. So it's the same kind of format here. In order to be a dilation, the x and the y have to be using the same scale factor. So here this is like a 1x and a 3y, so that is not the same, so this would be a what? Stretch. So it has to be like 3x, 3y for it to be a dilation. Okay, you should be okay with the pictures here. So I'm going to pause and let you guys try, or I'll pause the video and you guys can try to do the rest with your partner.
There's only one more.
Okay, so make sure your answers look like mine. Those are pretty simple, just to tell the difference between the two. Now we're going to work on the coordinate rules today. So it is very similar, the exact same process that we did yesterday when I saw you guys. But we're now doing it with coordinate points. So the difference is we're working from the origin. We'll do some later, but we're not working from the origin. Those are the more tricky ones. These are the really easy ones. So once we have a dilation with the origin at 0, 0, or the center at 0, 0, these are way easier. All you have to do is take your pre-image point and multiply it by the scale factor. Origin. Is that spelled right? It looks weird. That's right?
No. Yeah, it is.
Yeah, it's right. Multiply the original by k, or by the scale factor. We'll talk about slope in a little bit. If you notice this, the slope of that line, first of all, is it positive or a negative slope? That's a positive slope. Remember, negative slopes are going to look like that. We'll see that in a second. But we can always find the slope of this line, which we'll do for the other ones that are not on the origin. But if you notice, the rise and the run is going to end up being the same exact as my coordinate point. So my run is 1, which gives me my x value. The rise is 3, which gives me my y value. So we're just going to like skip that step. Instead of writing out the rise and run, which we'll do later, we're going to skip that step and just take our original point C. In order to find C prime, we're going to take our original x value and our original y value, and we're going to do exactly what the rule tells us. We're going to multiply by my scale factor of what? 2. So I do 2 times my original point 1, 2 times my original point 3. So the ones around the origin are super easy. You take that coordinate point, you multiply it by the scale factor. So my C prime will become what? 2, 6. So go ahead and graph that. Okay, so these are the simple ones. We are still using slope, but we're not writing it out necessarily. So this is more input-output. Questions there? Was that an enlargement or a reduction? Enlargement, because k was greater than 1.
You got jokes, man.
It's not mine. It's Mr. Riddle. Okay. Here we have a reduction because I have a scale factor of 1/2. I'm still around the origin, so I take my original 2 points here. I'm dilating a line. So I take my original point A and I multiply it by what? 1/2. So I'm going to do 1/2 times my original point 6 and half of my original point -4. When I'm multiplied by 1/2, what am I really doing? Dividing it by 2. So that is 3 -2 for A prime. Go ahead and figure out B prime and graph that. So again, we're still using rise over run here, but we know if it's starting from the origin that my coordinates do represent the slope already. So this is just another method, especially on questions on the EOC where you're not given a graph. Sometimes it'll just give you some coordinates and say dilate this by the scale factor or something like find the center, things like that. Okay. Okay, so that was a reduction, so it should have been getting closer to our origin or the center. So B prime, what'd you get, Elijah, for B prime?
What?
Vincent, what'd you?
What did it?
All we had to do was divide B.
Oh, you mean
By
1
2.
-4?
Yes. You got it.
Okay.
1 -4. Questions there? Okay. What is our scale factor here?
-1/3.
-1/3. So what does a negative scale factor do? Goes in the opposite direction. Is this a reduction or a enlargement? It's a reduction. So it's a reduction in the opposite direction. So it should end up, instead of moving it here, which should end up down there in the negatives. Notice that this is a negative slope here. But still moving around the origin, so this makes our lives a lot easier. You just take those original points and multiply it by our scale factor. If I'm multiplying by a -1/3, what am I dividing by?
-3.
-3. -3. Okay, you should have gotten D prime to be -1, -3, and -3, -1 as E prime. So it has gotten smaller, but it's also rotated how many degrees? 180, good. So that's what makes it the opposite. We rotate it 180 degrees. So the D and the E should be on opposite sides now. Okay, the 6 questions at the bottom of your page I do not have on here. But you should be okay to work through those with your partner. I'll ask for those answers in a second. But we're just taking our original point and multiplying by the scale factor there. I'll go over D, E, and F to make sure we know how to work with fractions. So I'll pause the video and let you work on that. Oops. Okay, what did we get for A? Fluffy, what did you get for A?
A, -6 and 10.
Good. Caleb, what did you get for B?
10, 45.
10 and 40. Fernando, what'd you get for B? 2 and 8. Okay, so I want to go over D and F. And do we do okay with E?
No.
You were
Oh, D divided.
You were dividing by -2. Okay, for this one, I want us to get used to working with fractions. I like working with fractions, so I don't like putting them in calculators or anything. So we're multiplying by my scale factor of 8. So what is any whole number over?
Divided.
Over what?
1.
Thank you. Over what? So when we multiply fractions, we multiply how? Straight across. So this becomes 8 over 8, which is 1. Uno.
What?
Uno.
It's easier to divide.
Okay. When we're doing 3/4 times 8 over 1, again, any whole number is just over 1. I multiply straight across. I get 24 over 4. 24 divided by 4 is 6. Question? Okay, this one, let's say you didn't have a calculator. Does anyone know what 2.5 is in a fraction form?
I don't know. I just multiplied it.
It's half of what number? 5. It is half of 5, so 5 halves. We're gonna multiply it by 2 over 1, so I'm gonna multiply straight across. I get 10 over 2, which is 5. 5 halves, we're gonna multiply by -4 over 1. When I multiply straight across, I get -20 over 2, which is -10. So you'll have to work with some fractions on your homework, so get used to fractions. No? Okay, this is at the bottom, so flip to your last page. This is at the bottom. This is the formula for when we have the center that is not the origin. So far it's been pretty simple, right? We just multiply by the scale factor. Here it's getting a little bit more difficult because we're at some point other than the center. Other than the origin, so not 0, 0. So this is the formula that we are supposed to use, and it looks crazy, right? You don't really have to remember this, but I'm going to kind of break it down here. So remember, this is our center of dilation. So you'll have an x-coordinate and a y-coordinate to work with here. So different because our origin is not 0, 0 anymore. So that will be an x value and a y value. Okay, our k is what? The scale factor. Okay, and then that is kind of our rule that we're using. So in the formula, it is just this side. That is the formula, and it's actually way easier than it looks. In the parentheses here, we have our run, and that is our rise. Okay, if you think about the x value is going to be the run because I'm moving to the right or left. The rise is going to be our y value. So we do have to figure out slope here, and sometimes we'll have to use the slope formula. So does anyone remember the slope formula? That's the slope-intercept form. But to find slope, we do y2 minus y1 all over x2 minus x1. So please write that down because sometimes you'll have to use slope formula if you're given 2 coordinate points. And then we can easily find our rise and run to plug into these values. We see our k again, so that's our scale factor. And then they pulled from your center the a, the x value of my center, and the y value of my center. So this will make more sense after we do it, but the only difference here is that we're having to add in our starting point or our center. So you're just adding in those values to add on to our length. from the origin. So it's basically what we've been doing, but we're now adding in our center. Things to remember here, we don't, once you find slope, you don't want to simplify it. If we're using it with coordinates, we want the actual values. Okay, so let's try an example. So this is back at the top of the page. Again, this is not the origin. This is the center of dilation is at T, which is -3, 4. So I'm going to write that again over here. So the center is -3, 4 at T. Just so we can practice with the slope formula, I'm going to have you guys use that here to find the slope of that line. I do know this is a positive or negative slope. So that's a positive, right? If it's moving up as we're going to the right, so it should end up as a positive slope. But let's go ahead and figure out, why is it freaking out? Using our slope formula, let's go ahead and figure out our slope. So we're doing our y2 minus y1. So since this is my center, I'm going to make that my first point. So that's x1, y1. And I'm going to make this my second point, x2, y2. Okay, so my slope formula is what's on top? You just wrote it down. What's the slope formula on the top?
y2 minus 1.
y2 minus y1. So I'm going to do 6 minus 4. Okay, now we're going to do x2 minus x1. So 2 minus a -3 becomes positive. We did slope formula together, right?
No.
A few weeks ago, 2 weeks ago. So 6 minus 4 is 2. 2 plus 3 is 5. So we want to figure out which one is my rise, which one is my run here. So this is rise over run, or my y values over x values. So since I know like an x comes first in a coordinate point, that's my end goal is finding a coordinate point here, I'm going to put my run value first because that's my x value. So that would be the bottom there, or 5. And the rise is the top value, which is 2, positive 2. I could have easily just counted that here, but again, sometimes you're not going to have a graph, or sometimes it's a little trickier to see if it's like a negative slope, so we'll see that in a second. But here the rise is 2, the run is 5. Okay, so that's my x and that's my y value. So we're going to plug it into that lovely formula to find g, oh no, that's h prime. So I'm going to make my parentheses really, really wide. So that is how we're going to find our new x and y value. The only difference here is that we have to add in our center. So I take the x value and I put it in the x side. Okay, so first step, I take my center and plug it in. So I'm going to put a 4 on the y side. Do you guys know where I got -3, 4 from?
No.
That is my center that they gave me. So that is the center. Okay, next step, we are adding the scale factor times the rise and run. Okay, we know that the run is my x value, so what's the scale factor that they gave me? 2. So I'm going to do 2 times my run of 5, because that is my x value. Okay, and the other side would be 2 times what? 2 times 2. Are you guys okay so far?
Oh, yeah.
Wait, what?
So I'll pause for questions and things like that, but just know this is what we've been doing, this scale factor times slope. That's what we were doing for the ones coming from the origin. Even though we didn't write it out as rise and run, that's what we were doing. So the only additional step from here is that we're adding in the center. Okay, so let's go ahead and simplify. So this becomes -3 plus what? 10. And that becomes
4 plus 4.
10 minus 3?
7. -7. Yeah, 7.
positive 7. Okay, this becomes 4 plus 4, which is 8. So my new coordinate for h prime is positive 7, positive 8.
That's it.
That's easy. You didn't have to go through all that.
Yes, it does seem like a lot of extra steps, but the next one you'll see is a little trickier.
Wait, so
You went to 9 instead of 8.
did you just follow this
Did I?
down here?
Alright, you mean I went 7? Oh, you mean I went up to 9.
And you're on that.
Oh, so it's here?
Or no, it is something.
7, 8. Is that right?
Yeah.
Okay, so it's kind of a mess, but the big takeaway there is that you want to add in your center first before we multiply by the scale factor. The next one, is a reduction. So this one's a little bit different, but same process. So my center that they gave me is what point?
8,
8, 1. Okay, I'm gonna go ahead and plug that in to my formula. So I'm gonna take my x value and my y value. I'm just gonna already do that, so I'm ready to go. Now I need to add my scale factor. So what is my scale factor here? 1/4. And then I'm gonna leave my parentheses just open so I can figure out what my rise and run are. Okay, what do you notice about the slope of this line?
It goes down.
It goes down, so it's negative, right? So it can be tricky to pick out which one would be negative, the rise or the run. It does matter here, so the best way to avoid that issue is just to use our slope formula. So I'm going to make the center my first point, so x1, y1, and I'll make G my second point. Okay, so I'm going to use the slope formula here. I'm going to do y2 minus y1, x2 minus x1. I could count, but again, maybe you're going to make the rise negative when it should be the run. So the best way to do that is just use slope formula. Okay, so 9 minus 1 is going to go on top. Oh, no. Yes. y2 minus y1. So I start second point to first point. And then that'll be all over negative 4 minus 8. So that becomes 8 over a negative 12. And then we don't want to touch that slope because that gave me my rise value and my run value. Remember, run is my x value, rise is my y value. So I'll let you figure out what your rise and run values are there. Okay, what is 8? Is that my rise or is that the run? That's the rise. Remember, this is rise over run. So I have a positive 8 as my rise and a negative 12 as my run. I kind of like to write it out first. You can always just plug it into your formula, but for my brain, it works nicer when I have all the x's on the same side. And all the y's. Okay, if I'm multiplying by multiplying by 1/4, what am I dividing by?
4.
4. So negative 12 divided by 4.
3. Negative 3.
Negative 3. I'm going to bring down my 8. And what does that simplify to?
5.
Positive 5. Okay, here I'm doing 8 divided by 4.
2.
I'm going to bring down my 1. 1 plus 2 gives me 3. So my value here, or my coordinate of G prime, is going to be positive 5, positive 3. Okay, so this is a 1/4 of the slope, or a 1/4 of my length, starting from the center T. A little weird, right?
I got
I guess so.
Okay, but again, like the biggest thing to remember is when we're not starting at the center, you want to always use that value there. You can always count your slope here, but like to me, I would have made that like a positive 12 and a positive, I would have like missed that step. Or like made it a positive 12 and a negative 8. So you always want to just double check with the slope formula. Okay, that is the end of those.